Here with Steve Chien, head of AI at JPL NASA. Steve, how's it going today?
Very good. I'm very excited to be here at the AI Summit and to hear a lot of great things that are happening in AI.
Yeah, fantastic. So you've just come off stage at your keynote a couple of hours ago. Can you tell me a little bit about it and what you're trying to really communicate to the audience?
Well, that AI is really being used all across the space exploration enterprise. Everything from making the spacecraft smarter to analyzing the huge data sets on the ground and then to operating things like the communications antennas that we need to talk to the spacecraft.
Yeah. So like a lot of the AI systems using space, right? I mean, I imagine they exhibit kind of a lot of autonomy, and there is more of a degree of, you can't control everything all the time. What can you kind of speak to that in terms of what could kind of these business enterprises learn in terms of implementing something that's actually autonomous?
Well, there's one aspect which is a direct relationship. There's a lot of business to be done in autonomous systems. So if people want to, let's say, drill for oil underneath the ocean or monitor their pipeline operations, it requires the same kind of autonomous operations and autonomous robotics that we're talking about, that we routinely develop at NASA. But there's also transfer at a more abstract level. So NASA has immense amounts of data that we have to sift through for scientific purposes and understand that data. And that's exactly the same thing that many companies are doing. They're dealing with the fact that there's this explosion of data and trying to figure out how to make it a routine process to understand that data and exploit that data to their commercial advantage. It's just that we're trying to do it for more scientific purposes. So there's a lot of crossover just in areas like that.
Sure. And your keynote was entitled AI and the Search for Life Beyond Earth. Can you talk to me a little bit about all that data you guys are sifting through, and why is it so important to kind of space exploration?
Well, the entire purpose of space exploration, from our perspective, is to advance science. And so the data is really the prize for sending a spacecraft. So we send a spacecraft to Mars, not for the sole purpose of sending the spacecraft to Mars, but to learn more about what Mars is like. And there are direct applications of this to all kinds of business enterprises. Companies want to understand more about their customers. Healthcare companies want to understand more about their patients. Different commercial vendors, in retail, want to know more about their customers and want to anticipate the customers' wishes so that they can, support their business more accurately, more quickly. And so these are all the same kinds of things that we've done, that we do work on at JPL.
And speaking to that, you have to put a lot of reliability into the systems you're using, right? Can you talk to me a little bit about that? What kind of advice would you give for building in reliability into an AI, system?
Well, that is one of the true challenges that we're facing in AI right now. As we have these software systems that are increasingly complex, how do we scale up our methods of verifying them and making sure that they'll behave properly? And there's been a lot of news in the press about autonomous driving cars. We don't have the ability to just test out a rover on Mars for, let's say 8 or 10 years or millions of hours. So we're a firm believer in traditional testing methods, but also in terms of formal methods, trying to be able to prove certain properties about our systems. And at some level, that's the only long-term alternative. And so I think that is the future. That's the future of all kinds of systems, not just autonomous systems, but any kind of system. You have to be able to understand what it does at a general level and show that it will behave a certain way.
Do you think technologies like AI remove the need for humans to become interplanetary?
I'm not quite sure I understood your question.
Do we need to really? Does this remove the need to send manned spacecrafts up into? If you can just analyze data from a distance using machine vision?
Yeah. So that's a very good question. So I believe that AI in space exploration is more complementary to human exploration. So first of all, at least for the foreseeable future, we don't have an AI that would be as good as having the scientists involved or having astronauts and go and explore themselves. And so for that reason, we want to send humans to these remote locations. But we want to send robots first because it's very expensive to send humans. So we want to learn everything we can with robots and then later on send humans. But even when the humans are there, they'll need robots because we don't want the humans spending their time on this mundane keeping the plumbing running and everything. We want the humans to be focusing on the truly intellectual tasks, and we want to relieve them from getting stuck in the mud of the day-to-day operations of the space station or the Mars habitat or whatever it is. So I think that human exploration and robotic exploration, they go together, the robotic exploration first, and then later on, the robots to help the humans. And this synergy is very important. There are some missions that we don't know when we'll be able to send a human on. So if we send a spacecraft to another star system, sending a human on a one-way 100-year mission is well beyond our current technology. But to send a robot, we could think about that now. We're not ready to send one, but perhaps someday.
Sure. And you've talked about kind of bringing the lessons of NASA's use of AI here to the other enterprises, but what is it about the companies here today that you're looking to really take home?
Well, to me, there are a lot of technical obstacles that are keeping us from moving forward, but there's a lot of what I would call business or people or process challenges to moving things forward. So I heard a lot of interesting talks on AI in healthcare, and they obviously have tremendous challenges because people's lives are at stake. How do you introduce AI? How do you decide how things are done? So this gets back to a question you raised earlier about how do we make sure that the rover does the right thing? Well, it's pretty important when it's a $2 billion rover. It's pretty important when it's someone's human life at stake. And so how you interject, how you infuse the AI into your overall process, those are sort of very similar questions. And so there are things about understanding the whole process, understanding AI in the context of the overall system, and also understanding the culture of the doctors versus the culture of spacecraft operations. These are all things that are lessons across these different disciplines.
What are the challenges of kind of building in, I guess, explainability and accountability, if especially in mission critical, kind of life-threatening situations? How do you see a way of overcoming those?
So this topic of explainability is one of the true challenges to AI right now. And most people talk about it in the context of machine learning, but my work is more on the side of model-driven AI. But explainability is equally important there. We actually have some very good technologies for explaining tactically what the AI systems do. So, when the car drives right when we expect it to go in the center, go straight, it's very easy to say, well, this particular thing triggered, and so it thought that there was an obstacle there. But that's not the deeper answer that we want. And what's the challenge to AI is to be able to explain like a human expert would explain. So the human expert doesn't say, well, this line of code triggered and then this line of code triggered. He said, there's this general class of white objects that we didn't really consider might be traveling at this trajectory, and so we need to reconsider our design in light of that. And that is the challenge, the current challenge with AI, to explain at what we would call the strategic level. And this comes up a lot in space exploration in terms of science planning. When we deploy our planning system and it says, you can't take that observation then, the scientist always comes to us and says, why is my observation not there? And we can say, oh, it's because the sun angle is wrong, the illumination is wrong for your observation, but that's not the real answer we want. The real answer is, well, it's because of these other observations, and if we change the trajectory this way, then we can get your observation, or we can take it at this other time. And so that's the next level of explanation that we need to get to.
Definitely. Well, Steve, thanks for talking to me today. Good to have you here.
Thank you very much.